Hello guys, let's learn about inverse of a 3 by 3 matrix. To get the inverse of a 3 by 3 matrix, first you start with what we call the matrix of the minus. We start with the matrix of the minus. And the matrix of the minus is given as follows. The matrix of the minus is given as follows. I'll take 6 from here. We have 6, negative 5, we have negative 6, we have 8, we have 1, negative 2, 2, negative 3, and 1. So what you do to get the matrix of the minus is that if you want to get the first element of the matrix, which replaces 6, you'll cancel this row, this column, and you cancel this row. You remain with a submatrix 8, negative 2, negative 3, and 1, which you are supposed to find the determinant of that matrix. Then, if I'm interested with this 5, the second element, I cancel this row, this column, and I cancel this row. I remain with negative 6, negative 6. I have negative 2, negative 2. I have negative 2. I remain with 2, and I remain with 1. Negative 6 because I've cancelled this row, this column, and I've cancelled this row. So I find the determinant of that submatrix. Now, if I'm interested with the third one, I cancel this column and I cancel this row. So that means I'll remain with this, remain with this one, remain with this one, and remain with this one. So I will have negative 6, I will have 8, I will have 2, I will have negative 3. Now I need to get the second row of this matrix of minus. So we have 6, negative 5, 1, negative 6, 8, negative 2, 2, negative 3, and 1. So now I'm getting the elements in the second row. That means I'm going to cancel this because I want the first element and cancel this row. So I remain with negative 5 and 1. Here I remain with negative 5, 1, then negative 3 and 1. Negative 3 and 1. Still need to get my second element. So I am interested with this one, my second element. So I cancel this column and I cancel this row. So I remain with these 6, 1, 2, and 1. So I have 6, 1, 2, and 1. To get again the third one here, I cancel this column and I cancel the same row. So I remain with this 5, remain with this, I remain with this, I remain with this, I remain with this. So we have 6, we have negative 5, we have 2, we have negative 3. So now we need to get the third row of the minus. So I still have my 6, negative 5, 1, negative 6, 8, negative 2, 2, negative 3, and 1. So I want to get the third row. So this third row does not appear anywhere here. These elements of the third row from the original matrix will not appear anywhere here. So I cancel, if I want to get the first one, I cancel this column and I cancel this row. I remain with negative 5, negative 5, and then you have 1, you have 8, negative 2. To get the second element, I cancel this column and I cancel this row. So I remain with this 6, 1, negative 6, negative 2. So I've remained with 6, 1, negative 6, and negative 2. To get the third element here, I cancel this column and I cancel this row. So that means I remain with this one, I remain with this one, I remain with this, and I remain with this. So we have 6, we have negative 5, we have negative 6, and we have 8. Something you need to take note is that if you compare this first row here, 8, we have 8, negative 2, negative 2, negative 6, negative 6, negative 2, negative 2, negative 6, negative 6, negative 8, sorry, 8, and then you have 8. That is just to be sure that your elements are not wrong. If I compare this row here, negative 5, 1, 1, 6, 6, 1, 1, 6, 6, negative 5, negative 5. Just to be sure that the elements of these minors is correct. Then you can compare this negative 3, 1, 1, 2, 2, 1, 1. We have 2, 2, 3, negative 3, and negative 3. That simply means that the elements of our minor matrix are accurate. The elements of our minor matrix are accurate. So we simplify this further. Now we find the determinant. We find the determinants here. The determinant 8, you take 8 multiplied by 2, that is 8. 8, here we have 8. Then you have negative 2, and multiplied by negative 3, we have positive 6. So 8 minus 6, that means we remain with 2. 8 minus 6, we remain with 2. Here we also have negative 6 multiplied by 1, we have negative 6. Then we have negative 2 multiplied by 2, we have negative 4. So negative 6 minus negative 2, that the minus becomes a positive, minus 6 minus negative 4. This becomes a positive, that means here we have a negative 2. So the second element is a negative 2. Here we have a negative 6 multiplied by negative 3, that is 18, minus 16, here we have 2. Those are row 1 for the minor. We go to the second one, second elements in the second row. The elements in the second row, we have negative 5 multiplied by 1, we have negative 5 minus, here we have minus 3. 1 multiplied by 3, negative 3, we have minus 3. This becomes a positive, and this is actually a 2. This is actually a negative 2. So the first element here is a negative 2. We have 6 multiplied by 1, which is 6, minus 1 multiplied by 2, which is 2. That means the second element is 4. Here we have 6 multiplied by negative 3, we have negative 18, minus negative 5 multiplied by this, we have negative 10. This, our third element, is negative 8. Still, we get the determinant of this 2 by 2 matrix. We have negative 5 multiplied by negative 2, this gives you 10. Negative 5 multiplied by negative 2 gives you 10. Minus 8, this gives you 2. 6 multiplied by negative 2, 6 multiplied by negative 2, this is negative 12. Minus negative 12, minus 6, negative 6 multiplied by this, you get negative 6. A plus and a plus, minus 12. Plus 6, you get minus 6. So here we have minus 6. 6 multiplied by 8, that is 48, minus negative 5 multiplied by negative 6, that is minus 30. This one you get 18, so we have 18. This is the matrix of the minors. So the next step from here is to get what we call a cofactor matrix. And to get a cofactor matrix, you take this matrix and you multiply with the identity signs. So we have 2, negative 2, we have 2, negative 2, we have 4, negative 8, we have 2, negative 6, and we have 18. So we have our identity matrix for signs. So we have a plus, minus, plus, minus, plus, minus. We have a plus, minus, and then a plus. So to convert this, Here we have a 2, a positive and a positive, we still remain with 2. A negative and a negative, we have a positive 2. A positive and a positive, we still have 2. Then a negative and a negative, we have 2. A positive and a positive, we have 4. A negative and a negative, we have a positive. A positive and a positive, we have a positive. A negative and a negative, we have a positive. And a positive and a positive, we have a positive. So this becomes our cofactor matrix. This becomes our cofactor matrix. The next step is to get what we call adjunct matrix. The next step is to get adjunct matrix, which is gotten by the transpose. This is gotten by the transpose of cofactor matrix. Transpose of the cofactor matrix. And the transpose of the cofactor matrix is simply interchanging the columns to become rows and the rows to become columns. And this is how we do the transpose. This is how we do the transpose. The column is 2, 2, 2. So this becomes my row. This 2 becomes 2. This 2 goes up. This 2 becomes a row. I go to the second column. We have 2, 4, and 6. So I start with a 2. This becomes 4, goes now to the row, and 6 goes to the row, to the second row. The third column here now becomes the third row. The third column starts with 2. Then we have 8. Then we have 18. This is my adjunct matrix. From this, the next step is to find the determinant. You can refer to the previous video where we have done the determinant of this, the full video for the determinant. However, the determinant of this matrix, the determinant of this matrix can be given in a simple way. I can pick this first row. I can pick this first row here. I can pick the first row. So we have a 6. I multiply by 2. The sign is a negative, so I pick negative. Then we have negative 2. Sorry. To get the determinant in a shorter way, we can pick this, any of the cofactor matrix row. So I can start with 6 here. Here we have 6. I multiply by the 2 in the cofactor matrix. Then I go to negative 5. Multiply by a negative, that becomes a positive 5. Multiply by a negative 2. Then I pick 1. The sign is a positive. I multiply with 2. So that gives me 2. In other words, here I have 12. I have 12 minus 10 plus 2, which is actually 4. This is my determinant. So the inverse is given by 1 over 4, which is our determinant. Then we have the adjunct matrix, which is 2, 2, 2, 2, 4, 6, 2, 8, 18. This becomes our inverse. This becomes our inverse for this matrix. Thank you.